Okay, well, I think I'm ready to pretty much call this project done and wrap it up. You can see I got the screws in and the displays are screwed into the bracket. And then if we look around on the back, the wiring, such as it is done. This is just all directly soldered with some 16 gauge solid core wire. There are removable headers in the Arduino, but for the most part it's just hot wired. One interesting thing that did come up, I don't know if it'll show up here, but you can see this very poorly resoldered surface mount capacitor there got knocked off because it interfered with the plastic frame, and so I just melted a divot in the frame with the soldering iron and put the cap back on, but even that one on the right of it is kind of close. Other changes in this version, I added a capacitor, a filter capacitor there for the voltage divider so that it'll reduce the jitter a little bit. There's some changes in the software also to try to remove ADC jitter, mostly copied from the PwrPanel source code itself. There's also a header here, this 3-pin header right there, which connects to the TTL lines from the PwrPanel itself. And I just made a connector or a cable using a servo wire and a Futaba connector, which I'll show you here in a second. But this guy is pretty much done. I also designed and 3D printed a little bezel here, complete with my call sign, that fits over the outside of everything and kind of hides the non-visible portions of the TFT, and you know, it actually adds a nice little dress up to it. Meanwhile, in the Go box itself, you can see the wiring here. This is that cable I was talking about with the Futaba connector that just goes to the TTL output on the PwrPanel, and then there's a 16 gauge cable with Anderson power poles that then just goes to a barrel connector, and then I can just plug that into the Arduino. So these two cables are all that are needed to power it up. So I'm going to go ahead and put it in the rack, and then I'll show it working. Okay, well here we are. The panel is installed in the rack, and it's been charging for a while. It's plugged into AC power, and it's actually really interesting here. You could start seeing on the graph that even though it's in constant current mode, and it says the pulse width, if you look in the bottom right, is at 100%, as the voltage of the battery starts going up and approaches the voltage of the power supply, the actual current flowing into the battery tapers off, and so the PwrPanel will probably be transitioning into constant voltage here pretty soon. I think it does that around 14.3 volts. So a couple other things to mention about the firmware. The first one is I changed the graph so that it is, each data point on the graph is about 15 seconds. That makes the graph itself about 40 minutes wide. And it lets you see these longer trends, like the blue line of the battery starting to arc up and the current dropping off. And then also on the fallback voltage, which is what I'm calling it, the voltage divider, I realized that the reverse power protection diode in the Arduino, which was upstream of where I was measuring the voltage, had about a half-volt voltage drop. So I measured the voltage drop with a multimeter and then just added code to the firmware to add that in. Now what we're seeing right here while the PwrPanel is on is the battery voltage as it reports, and that is not subject to a protection diode in that way, or at least from my reading of the firmware, it doesn't look like they're compensating for it, so I'd have to double check the schematic, but I'm pretty sure that that voltage doesn't go through any diodes before it's sampled. But there we have it. I'd say overall it's a pretty successful project. I turned on the radio so you could actually see it doing its thing too. There's no antenna hooked up right now. I still need to test it with solar power. I haven't tested the firmware with solar because it's been raining nonstop, but hopefully maybe after Christmas I'll be able to get the panels back out and look at how the graph works. If you look at the graph here, the very bottom line that's in yellow is supposed to be solar wattage as reported, and it should work. I mean, it's just reading the serial data to get it, and I know the serial data is being parsed correctly. But anyway, there we go. One PwrPanel monitor.